లో యాసిడ్స్ అండ్ బేసిస్ టాపిక్ గురించి తెలుసుకుందాం. ఈ టాపిక్ లోని బ్రాన్స్టడ్, లౌరీ అండ్ లూయిస్ థియరీ గురించి కెమిస్ట్రీ బోధనలో 20 ఏళ్ల అనుభవం ఉన్న టీవీఎస్ శంకర్ గారు వివరిస్తారు. మరి ఆ వివరాలేంటో ఇప్పుడు తెలుసుకుందాం.
Welcome to KABTV e-classes. Today we will be discussing regarding acids and bases, which is otherwise called even ionic equilibrium also. So before starting the topic, let me introduce myself to you all. I am Shankar and presently I am teaching at Bangalore in the IIS institutes. Previously I was working at Hyderabad and Chaitanya institutes. Now let us go into the topic, that is regarding acids and bases. And technically this term is also known as ionic equilibrium. So the importance of this topic is in IPE, the actual weightage it comes to 6 marks and sometimes 8 marks also they are giving us. Thinking that the 2 very short answer questions and then 1 short answer question is being given in all the previous classes or previous years we can say. And then one of the 2 years back they have asked even essay type question also in this topic. So the main idea is that we'll just brush up the main points in this topic, and the topic entirely goes in terms of the IPE examination only, not the objective orientated there. So now let us enter into the main topic. Now basically there are many theories of acids and bases. The previous very good old theory was proposed by Arrhenius. It was known as Arrhenius theory, and there are many drawbacks and its limitations of the theories are there. So presently we are not discussing about Arrhenius theory, we straight away start with the Bronsted-Lowry theory and Lewis theories of acids and bases. This Bronsted-Lowry theory was given by 2 scientists independently. One is Bronsted, other is Lewis, and together they have postulated some of the important points or the definitions we can say rather regarding acid, base, neutralization. Those things we will be taking up one by one. So we will be starting with the Bronsted-Lowry theory of acids and bases. So first theory in the acids and bases here, that is Bronsted-Lowry theory. So previous to this, there was Arrhenius theory is there. Arrhenius theory is basically applicable only to the aqueous solutions only. And one more thing, it could not explain the acidic nature of gases like carbon dioxide or sulfur dioxide, and then the basic nature of ammonia, calcium oxide and so on and so forth here. Therefore, this theory is a more general and more simplified theory when compared to Arrhenius theory. Now in this theory, first of all, the definition regarding what is acid as per this one. Now here, any substance which can donate a proton to another substance, that is defined as acid. So all simple protonic compounds can be considered as acids. For example, so HCl or else HNO3, H2SO4, CS3COOH. Like this, all these compounds can be considered as acids as per this theory. So one word to say here, the acid means in this theory, it is proton donor. So any substance which can give proton to other substance, or a substance which has a tendency to give proton to some other substance, that is basically defined as acid in this theory now. Now when you take a reaction like this, say HCl plus H2O giving rise to, it forms H3O plus, that is HCl. From HCl, proton is being given to water, thereby it forms H3O plus and then Cl minus. So since in this reaction HCl is giving proton to water, so HCl can be considered as a proton donor, nothing but an acid as per this theory for us. So HCl is a proton donor. Now coming towards the meaning of base in this theory, now we can understand from this itself, that is any substance which is in a position to accept proton from some other substance, that is considered to be a base. Means in one word to say, a proton acceptor is considered to be a base in this theory. So in one word it is proton acceptor. So therefore we can take all, for example like this, say OH minus, Cl minus, Br minus, and even in this case water molecule also, ammonia, etc. all these substances will be accepting proton. Therefore, these things can be considered as bases here now. So in this theory, one more advantage is that not only molecules, even ions can be defined as bases or even acids also. Coming towards the meaning of neutralization here. So neutralization. Let us take a reaction, or you can take this reaction itself. Here one substance is giving proton to other substance. So proton transfer is taking place in this reaction. So this reaction can be considered as neutralization according to Bronsted-Lowry theory. So therefore basically acid is coming as a proton donor and a base is coming as a proton acceptor, and neutralization reaction means it is basically a proton transfer, that is from one substance to the another substance we have. This is regarding acid, base and neutralization. Now there are some more salient features of this Bronsted-Lowry theory. Something like conjugate acid-base pair is present, and how we are defining the strength of acids and bases. Those things also must be taken into account here. So if we take those things here, first of all let us see the conjugate acid-base thing. So that is conjugate acid base pair. Now what is the meaning of this conjugate acid base pair here now? If you take any reversible neutralization reactions, something like say HCl plus water, or you can take even ammonia and water also, HCl plus H2O, which is giving rise to H3O plus and then Cl minus here in this case. So here if you are seeing the reversible reaction, in forward direction HCl is giving proton to water, therefore HCl is considered as a acid for us. If you are seeing the backward reaction here, then the hydronium ion, that is H3O plus, is giving proton to Cl minus for us. So this is considered as acid for us. And if you are seeing the relation of water and Cl minus, water is accepting hydrogen or proton from HCl. So therefore water is considered to be base in forward reaction. And then in the backward reaction here, hydronium ion is giving proton to Cl minus. That implies Cl minus is accepting proton from hydronium ion. Therefore we can say that Cl minus is a proton acceptor, nothing but a base for us now. So in this complete reaction, we have two acids are there and then